Lecture number 29, which is about NFTs, non-fungible tokens, ERC 721 tokens and metaverse. In this lecture, we will see how non-fungible tokens can be traded and how it is leading to the evolution of the metaverse. All this metaverse is related to the one of the kind of parallel world. So we'll see the details of each of this topic in this lecture. Coming to the society 5.0, if you see the industrial revolution, so the first industrial revolution was in the 18th century, where craft production and business was happening with the shops. After that, during second industrial revolution, factories have come and mass production started. In industrial revolution, late 20th century, with the advancements in the computers and networking technology, the automation started. Along with that, the cyber physical systems, AI, cloud computing, all are being used in the production system. Fourth industrial revolution, which is in the early 21st century, where it is considering the Internet of Things, cyber physical systems, digital platforms, product services. So you can take the example of smart grid, which we have already seen, which is like involvement of the ICT infrastructure with the traditional electricity network. So that integration has given the fourth industrial revolution. Coming to the fifth industrial revolution, where the goals are sustainable systems, better human life, so human-centric system and resilient system. And with the advancement of technologies, the complexity is also being increased. So if you see the society 5.0, along with the industrial revolution, the society 5.0, when it was started with the society 1.0 was the hunting society. Then agrarian society, it was considered as like society 2.0. Then due to the industrial revolution, society 3.0 came. Now we are living in the society 4.0, where we are using the ICT infrastructure, computer-based technologies and various services. With the evolution in the different domains like digital transformation, AI, IoT, blockchain, it is a part of the now society 5.0. So this is what about society in the physical world. Now with the advancements in the AR, augmented reality, virtual reality, parallel world is also started. That is called as a virtual world. But the key enabler of the virtual world are the technologies like AI, AR, VR technology, IoTs, sensors, blockchain and cryptocurrencies and non-fungible tokens. So I will start with the non-fungible tokens. Already cryptocurrencies we have seen in this course. So non-fungible tokens can be called as the unique digital asset which is stored on the blockchain, which is representing the ownership and authenticity of the specific digital contents. Those digital contents can be your art, collectibles. I can say your smart contract, whatever you are writing smart contract, that is also your non-fungible token, because that is developed by you. And if it is deployed on blockchain with your ownership, then it is called as a non-fungible token. Those non-fungible tokens, you can trade it. Its value will not get changed. So try to understand the difference between the non-fungible tokens and fungible tokens. Fungible tokens are the cryptocurrencies which value can vary which value is being changed. But fungible tokens value will provide the uniqueness of that value. Sorry, fungible tokens are having the uniqueness feature, which value is not being varied. It is up to the creator at what rate creator would like to trade it or sell it. But uniqueness feature is there. So it is providing the kind of digital certificate of the ownership, that this particular digital asset is belonging to you. It allows creators to monetize their work and buyers to own that unique digital items. Coming to the physical items, let's say I am creating one of the good picture which you are seeing in art gallery or in auction, and people are purchasing. That is about the physical items. I am talking about digital item for which we require the security. I am creating one image, anybody can copy that image and can trade it. So it is difficult to prove the ownership, but such tokens are proving the ownership, that this token is belonging to you. So NFTs are collectibles which is having the uniqueness, can be like digital art, gaming items. So gaming items, you might have seen that in game we are having the different objects. You can also introduce more objects if it is allowed by the service provider, or if it is like different kind of gaming. So that will come later, that in which type of game you can create your own objects. Coming to the coins within the game. So most of you are playing the games, online gaming, where you can see the number of tokens which you are earning. That token is also called as a non-fungible token, because its value is lying within that particular game. But blockchain can allow you to trade or sell those tokens in other games also. So the best example for that is the Roblox. With Roblox, you can have the common account. You are earning the tokens from one game. Those tokens can be redeemed to the another game also. So ultimately, Roblox account is your wallet, which is storing your tokens which you have earned, and that is producing the value. So NFTs on blockchain prevents the unauthorized tampering of your unique asset. It is preventing the replication also and destruction. It assures the ownership verification on blockchain network, which is offering the extrinsic value of the NFT. So this is the history of NFT. So quantum NFT, which was introduced in 2015, it is like first NFT on the blockchain, which is created on the Namecoin blockchain in 2014 by Kevin McCoy. So quantum NFT, if you see the right side, it is a like pixelated octagon which changes colors and moves like an octopus. So this is like one of the digital art, and this digital art is a NFT, and which gone through the auction, and for a staggering price of $1.47 million. So you can understand that how NFTs are creating the new revenue stream. You, by sitting at your home, you can create the digital art which should have the uniqueness. With the help of such a digital asset, you can generate the new revenue. Then another example is like Spell of Genesis on Bitcoin, which is the first NFT trading card game. Then Rare Pep Revolution. This is the artwork you can see here. It is called as a Rare Pep, and this is being used for the various purpose. But the ownership is within the creator of this Rare Pep. Then CryptoPunks, which is generative NFT art collection developed by the Larva Labs. Then CryptoKitties. There are many examples of such NFTs. And that has given a birth of the metaverse, because in decentralized, that we'll see later, that centralized and decentralized metaverse, but NFTs can be traded in the virtual world also. So digital arts can be created in the virtual world and it can be traded through your wallets. So that decentralized land is the decentralized metaverse. We'll see the difference between centralized and decentralized metaverse. So central land is the one of the example of decentralized metaverse where users are allowed to purchase and share that virtual land parcel. It is like crazy that earlier days people were interested to purchase or sell the land in the physical world. But here in virtual world also you can purchase and sell the land. So that means in virtual world that land object is having value through which you can earn the coins or you can sell those coins. Why NFTs? It is like secure verifiable ownership of the digital asset. It is creating the new revenue streams for the creators. It is having the ability to foster the communities and collectible market. If I'll say that I am having the old 1 rupee coin, to sell it or to trade it or to put it in an auction, for me I have to put lot of effort. But if same item is available in the digital form, in the form of the NFT, for me it is like very easy to trade it, sell it, or I can earn the money. But because it is having the uniqueness, it is my collectible which is with me, and I am the owner of those collectibles. It allows transferability. You can transfer your collectibles from one account to the another account also. Authenticity. All the NFTs can be authenticated. Now the question will come, what is the difference between NFTs and cryptocurrency? Both are in the digital form. If you see, cryptocurrencies are also in the digital form, NFTs are also in the digital form. But NFTs are having the uniqueness, where cryptocurrency is not having uniqueness. If I'll transfer 1 Bitcoin to you, you will be the owner of that Bitcoin. But you cannot identify getting that Bitcoin whether it was belonging to the who. Fine. NFTs are provided, like every NFT is a unique value, or I can say uniqueness is there. That can be traded, exchanged for one another with no loss of value. But cryptocurrency can have the loss of value based on the demand supply. And there are many factors where value is being increased or decreased for the cryptocurrencies. But in NFTs, values will be not increased or decreased. It is up to the owner. Target use. And NFTs are the type of digital collectible items, much like art or wine. But cryptocurrency can also be collected. Cryptocurrency can also be collected. Through the purpose is not as a collectible, but it is like form of the payment. It is in the form of payment that I am doing payment with the cryptocurrency. But NFTs cannot be done as a like form of payment. It is kind of like I am transferring those NFT from my account to your account. Means I am selling to you. So we require the standards at that time. So Ethereum is providing Ethereum request for comments, ERC standards for such NFT tokens. And there are many proposals have come, which is like Ethereum improvement proposals. So you can see the list of Ethereum improvement proposals for the NFTs and the fungible tokens also. So few of the tokens I am explaining here. ERC20, which is a standard interface for the fungible, or we can say the interchangeable token, like voting token, staking token, or the virtual currency. It is fungible. ERC20 is the standard for the fungible token. ERC721, which is non-fungible token standard, where set of procedures and functions are mentioned to utilize such tokens. So it is like a deed of for the artwork or a song. Suppose you have composed one song, that is also your digital art, I can say. And it should be like non-fungible. You should be allowed to sell, or it is like your own artwork. So ownership should be with you. It's same kind of like copyright on the digital content. So you are having the ownership of those contents. But there are I can say semi tokens also, which are fungible as well as non-fungible. So that standard is the ERC 1155, which we can say that it is providing both the purpose, fungible as well as the non-fungible, and that is called as a multi-token standard. It allows for more efficient trades and bundling of the transactions, and it is saving the cost also. It allows for creating both utility tokens, fungible as well as the non-fungible also. So it can be used as like cryptocurrency as well as the non-fungible tokens also. In this lecture, I will focus on ERC 721 as we are talking about the non-fungible tokens. So ERC 721, it is a standard on the Ethereum blockchain. That is the NFT standard. Already I explained that ERC 721 is for the non-fungible token. Initial ERC specification was proposed by Sadly as an Ethereum improvement proposal. After that, it was again revised by the same authors. The ERC standard, which consists of the set of functions which developer can implement in smart contract to create, transfer and manage the NFTs. So here set of functions are there which can be implemented in the form of smart contract, which will allow you to create, transfer and manage the NFTs. So with this you can create your own digital token, NFT tokens. You can manage and you can transfer to the others or sell it. ERC 721 smart contract, which is maintaining the record of the token ownership, that who is having this token. Fine. So that will allow for the transfer of tokens between the users also. Value will be same. Also, it is keeping the track of the total supply of tokens and the balance of tokens owned by the individual address also. So that is what it is managing the tokens. And there are n number of applications for such non-fungible tokens in gaming industry. So gaming, artwork, collectible and many more. So that we'll see later when I'll start covering the metaverse, that there are n number of fungible I can say examples, non-fungible token examples, which we'll see during the metaverse. ERC 721, as we have seen that it is allowing users to have, so you can keep it, you can transfer, you can manage your unique digital assets. You can have it. The question will come, why I should keeping that? Why I should keep? It is a uniqueness. It is having the uniqueness feature. You can sell it later also. Fine. Because it is your collectible. It is not cryptocurrency. Fine. It is not cryptocurrency. It is collectible. It is providing a like new avenue for the work. Whatever work is there, whatever work you are doing, for that you are getting the credit. In the gaming industry, this is the example where game developers can create uniqueness or unique game items in the NFTs. I'll take the one example. Now on WhatsApp, if you see that earlier we were using only emoji. Now avatar is also there. Is it NFT or not? Can you find same NFT, same avatar in another game? It is the uniqueness of the WhatsApp. It is allowing you to create, it is taking your picture, it will allow you to create your face, it will show body structure, which one you want to prefer, color and many other things. Those are like NFTs. Those are like NFTs, which is not available to the other platform. Other platform can have their own such NFTs. So this is one of the example of NFTs, but that is not being traded on the blockchain. But this is the digital art, which is created by the WhatsApp. So such NFTs are transforming the number of other industries by allowing individual to have the stake in that digital landscape. So non-fungible gaming asset. Earlier days when we were going to the shopping mall, they were showing the 3D picture. We have to wear that device and you can see you can experience that 3D game. Fine. In that various objects are there. Those are film based, or I can say digital based objects. Just it was showing that you are experiencing that. Now, but in that you cannot interact. You can just experience. With the help of this NFT, you can interact with all the objects within that particular digital landscape. You can purchase, you can sell, you can enjoy those objects also. So this is the difference between that time of virtual reality and the current virtual reality. Okay, here interaction is provided, not only experience. You can interact, you can utilize, you can sell it, you can sell it, or you can buy the objects also. Metaverse land and asset. Then Web3 community membership, and many more applications are there for the NFTs. I'll cover each of those applications and how it can help in the other, I can say, application. It is not only for game. Those who are not aware about the metaverse, they will say that, okay, metaverse means game only. You can play and you can earn the tokens. No, that is different metaverse. That was the birth of the metaverse, I can say, which was the centralized. But it has created now that metaverse is evolved with the decentralized, where you can develop n number of different applications. So those applications I will cover later. So metaverse, actually it is this term is based on two words, meta and verse. Meta word is taken from the Greek language. The meaning of that word is the more comprehensive, transcending. Verse is abbreviated form of the like universe. Fine. So that means metaverse is like a kind of virtual world, which you can experience by sitting at room, or by sitting at some remote location you can experience it. So this term was coined by the Neil Stephen in 1992 in science fiction novel called Snow Crash, where people utilize digital avatars to control and compete with each other to upgrade their status. So the traditional social systems can be transformed into the novel digital living space. I'll tell you the examples. I want to experience Singapore. I don't have that much money to go to Singapore. How I can experience Singapore? With the help of this technology, by sitting in a room, you can interact with all the objects, all the shops, all the, I can say, means you can visit that Singapore country. And you can experience Singapore country. Similarly, like let's say, I am creating the virtual world of the Goa. Those who are not able to come to Goa, they can experience the Goa, they can experience the whatever available in Goa, everything can be experienced through such virtual world. That means our social system is being transformed to the digital space. It is offering the robust infrastructure and the enabling technologies for the metaverse is the like blockchain, AI. So whatever avatars are there, that is based on the AI, which is taking your different preference your image is, and it is generating the avatar which is almost similar to you. Now think about the virtual world. You have created one avatar, your friend has created one avatar. Both of you are meeting in the virtual world. Both of you are playing one game. Your avatar will also be there, your friend's avatar. So you can interact through the avatar. And by using the VR technology, AR VR technology, you will realize that you are talking to your friend. That experience you can get. But it is in the virtual world. Your friend is not with you. But still you will experience that you are talking like same like the in physical world. Then 3D modeling. Already I mentioned the augmented and virtual reality. Spatial and edge computing, obviously we require the computing power. So cloud computing, edge computing will always be there. Internet of Things and digital twins, which are taking the physical world information and creating the virtual world with the help of different technologies. Metaverse is built on decentralized, accessibility and user-friendly experience. These are the three main pillars of the metaverse. It should be decentralized, it should be accessible, and the user-friendly experience. A shared persistent virtual world environment where people can interact just like in the real world. So think about, I want to conduct the meeting with my friends who are not in India. I can use the Google Meet. I can use any of the, I can say, medium for meeting. The experience which I will get with the metaverse, which will be different, because the platforms for the, I can say, online meeting, where I can send the message, I can send the voice. But I may or may not be able to feel like I am in the real world. Metaverse will give the experience same like the real world, although your friends are in the other country. So people can work, people can live the life and play with friends from any place in the metaverse. One most prominent example of metaverse is the attempting to create such a virtual world was the Second Life. I don't know how many of you are aware about the Second Life. That implementation is for the gamer community and beyond. A metaverse is not a single world, virtual world. Suppose let's say, I want to experience the moon. How is the life on moon? I cannot go to the moon. But based on the moon related historical data, if such virtual world is created, I can experience the life on the moon by sitting in one room, just wearing the devices and technology. User can get, so you can not have only one virtual world, like multiple virtual world also can be there. You can move from one virtual world to the another virtual world also with the help of metaverse. Users can navigate from one virtual world to the another through the portals or other means of transportation. Users can interact with each other and with digital objects also, creating the sense of immersion and presence. I can purchase the item, food item. I don't know in future also, if you are purchasing some items, let's say eatable items or food items in the metaverse, and you are experiencing that you are eating, but actually your avatar is eating, and that is the revolution may happen, and you will not feel hungry also. I don't know how much it will be successful, but that thought process is also there, where you can experience the virtual world. In virtual world, you are eating, you are playing. Suppose I am playing one football match in virtual world. I will feel tiredness. This is now linking your virtual object to your human object. In many of the movies we have seen that this is happening, that if you are into the virtual world, take the example of Matrix. But that is the thought process. and thought process can come into the reality by putting lot of efforts. So this can happen. It is having potential to be massive economic and culture force. With the rise of online gaming and social media, such platforms can create massive community and generate significant revenue stream. You can create your own, I can say, social network. You can talk, you can chit chat in the virtual world. You may not be knowing the person behind that avatar also. So obviously, along with such advantages, disadvantage can also be there, where people can manipulate you also. You can be stressed also. And there are certain, I can say, attack scenario in the threat model, where it is saying that cyber bullying can also happen. Bullying of the kids can happen. Fine. And if attack on avatar is happening, although you are male, but your avatar will so look like female, then kids will get embarrassed and they will go into the stress. So such issues are there. Those issues should also be resolved before I can say widely adopting such technology. But with respect to the advantage, it is having the promising, I can say, applications which can help in reality. So this is the metaverse history. In 1992, as I mentioned that this term was coined by the novel Snow Crash. In 2003, second life came. 2006, Roblox. Roblox is now a widely popular game. So people are, actually it is giving one platform where different games are there. It is not using VR technology. Just you can play in mobile also, but you can feel that you are into the virtual world. Where your friend will also be there, you will come to know that where is your friend. You can identify and you can play the different games. Then Decentraland, which is Ethereum blockchain based project, which was introduced in the 2015, aiming to create the open virtual world. Then Sandbox in 2018, then Mark Zuckerberg changed the Facebook company name to the Meta. And after that, the growth of metaverse is also increasing in different domains and applications. So these are the different examples of metaverse landscape. Second Life, which is the virtual world. It allows to create avatars, interact with each other in 3D environment. It is having its own economy, where user can buy and sell the virtual goods using the real money. And there are many examples where kids are addicted to such games, and then they are paying lot of money, or maybe attack also, but they are paying money to purchase such objects. In physical world, these objects may not have value, but in digital world, it is having value. So all these such objects can be called as a non-fungible tokens, which is having the value. Minecraft is a massively popular sandbox game which allows players to create and explore their own virtual world. So Minecraft is also, I can say that it was widely popular, widely used game. Then Fortinet VR Chat. Fortinet is the battle royale game. That is also metaverse. VR Chat is a social VR platform that allows users to create and explore the virtual world with each other. Roblox, I think I need not to talk more about the Roblox. It is widely used game, giving the common platform to play in different games, and it is having its own economy where you can sell and purchase. Yeah, coming to the old games. On Facebook and other platform, where I can say that software as a service kind of games or application as a service kind of games, where whatever coins you are earning, those coins you can redeem within that game only. But if such platforms, if you see the Roblox, where you can earn the coins from one game and you can redeem those coins into the another game, that means those coins are having value, which you are able to utilize to get something. Here you are getting entertainment. So entertainment is also having the value in this metaverse. Social interaction has potential to revolutionize social interaction. Obviously, chat-based and video-based, compared to the chatting-based or message-based interaction, experiencing the, I can say, same like the physical world, if you are interacting in the virtual world, that experience will be always better than the message-based interaction, or I can say video-based interaction. Education, yeah, metaverse can have the potential in the education system. There, forget about the challenges. I am talking about the benefits. In education, take the example of COVID time. No students were able to come to the college, even no people were allowed to go out. But I want to conduct the class. So everywhere, due to this digitalization, digitalized platforms, using Google Meet and other platforms, online classes were conducted. But still, it was difficult to experience that I am sitting in a real classroom. I am getting, there is no interaction. But if all students are joining in metaverse platform, classroom, teacher will also be there in that classroom. That teaching will be same like the physical world. In certain situations, it will fulfill the goal which is being fulfilled in the offline classes. Then commerce. So this can range from the game items to the virtual real estate also. It is not about like metaverse is not about like you just purchase or sell the items or game items. I can create, let's say, once I can purchase one land and I can purchase, I can establish one shop to sell the good items. Now I want to sell that particular shop also. I can sell it. And people can buy it also. Because those are like my non-fungible tokens. So you can understand that NFT is changing the world. Obviously, along with NFT, enabling other technologies are there, but NFTs are playing a better role. Otherwise, what will happen? As I have spent my time, effort and money to create those digital arts in metaverse, but if NFTs are not there, it is difficult to prove the ownership. It is difficult to prove the ownership of those such NFTs. So NFTs are helping a lot. Similarly, entertainment. There are many TV shows, movies popular, where fine. You can go around that. You can interact with all the actors. And you can enjoy that one. So in entertainment also, metaverse is having the application. Work environment, like office or industry, compared to the traditional video conferencing or messaging platform, you can create the virtual, I can say virtual chat room. But again, security features are important because it should be like private chat room. That nobody should be there because you are exchanging the sensitive information, maybe business related information in such chat rooms. In physical world, if someone is listening or someone who is not allowed to listen that interaction, you can easily identify. But in metaverse, the person can be there in chat room which and who will not be visible to you. Such kind of attacks can be happen, and such one of the kind of such attack is the man in the room attack. So you can explore it further. What is man in the room attack? I am just giving introductory part of the man in the room attack, where you are having the private chat rooms where only authorized users are allowed to interact. And if any unauthorized entity is there, which you will not be able to see in metaverse. But that person can listen all your communication from the private chat room. So man in the middle attacks can be possible. So security is always required. Coming to the health. Suppose, let's say, I want to do some practice on certain surgery. This is the first time I am doing. Should I do it on some live human? No, I will not be successful. If I am not successful, it is impacted different. I can do such practice in the virtual world, where live person will be there, but live person will be the digital object. And I will do that surgery and I can see the impact of it. What will happen if I will do surgery in this procedure? Similarly, you can think of tablets also. You give your tablet to such test, see the impact. Fine. Where it will not affect to the human life, any human life. Fine. So such applications are there in the health sector also. Similarly, industry. I want to construct one house. That can be like unique design. But whether it will survive in this climate or not, whether it will be sustainable or not, how I can test it? I cannot construct and wait for the 2 or 3 years to check whether it is proven design or not. I can experience that in the metaverse, which will not affect to my money, because it is like reducing the cost. Similarly, in the industry, wherever automation process is there, full automation process, you can design your manufacturing industry within the metaverse and you can experience whether it will work fine or not. You can identify the faults also, and then you can deploy really in the physical world. So like this n number of, means whatever it is happening in the physical world can be experienced in the digital world. That is what the metaverse. Already I gave the example of different metaverse. There are mainly two types of metaverse, centralized and decentralized. Centralized metaverse are owned by the creators, and all the users have to rely on the creator. So the control is given to the centralized authority who has created. Like Roblox is centralized, where you are not owning anything. You are the user, where you are creating your account and you are taking that experience. You are not the owner. But decentralized, where each user is the owner. You can create your own asset, you can trade it, you can sell it. Control is not given to the one entity, control is within the decentralized network. Same like the blockchain. The control or ownership is ownership of that platform is among all the nodes. So these are the various examples of centralized and decentralized metaverse. Coming to the architecture, so this architecture is provided by as per the Deloitte analysis. At back end, you will have application layer, network layer and perception layer. Interactive technology, hologram, sensing technology, AR, VR, then hand gloves. There are various technologies, sensor-based technologies are there. All can be utilized to interact with the metaverse. Because those sensors are sending data and accordingly action is taking place. Then random interaction, video game technology, 3D engine, real-time rendering, space rendering. Underlying structure of such is, it is using 5G and obviously 6G is also there because we require this speed. Cloud computing, edge computing, it is using the blockchain technology, computer vision, machine learning, natural language processing, intelligent voice also, As I said that you can interact. Interaction is not through message, through speech also, through visual objects also. So we require the 3D modeling, means video processing is required. Machine learning is also required to create such objects. So AI ML is also playing a major role in the construct of the metaverse. Natural language processing. Suppose I am speaking in one language, my friend is not understanding in metaverse domain. Then language conversion should also take place. Or suppose in metaverse platform only English language is there. I don't know English language. So it will reduce the number of users. To expand it, suppose if I am speaking in Hindi, conversion should take place in English. So suppose if I am in the chat room, or if I am in the meeting, I am not understanding other country language, I can speak in English, it will be translated into that country's language. So natural language processing is also required. And what kind of applications? So you can have the virtual identity like virtual plan, open office, virtual design, virtual modeling. All these are, I can say, enabled through the digital twin. You can have the real factory. So this is like at real factory, you are having the manufacturing, monitor and control. This data is going to the virtual factory. So you can have the whole virtual factory. And experiments can be done in the metaverse in this virtual factory, and that experience can be brought to the physical factory. So you can have the virtual office, virtual meetings also. Then at consumption end, you can have the employee maintenance, product training. So product based training, you can do the sales and marketing practice also. And you can see the impact whether it will be sold or not without going to the each individual door. So this is also one of the architecture which is also given in this paper, where interaction is with the human society. Obviously, to develop the same virtual world, you need to get more information from the where? Real society or real world. So obviously interaction is always required between real world data to the virtual world. So it will require the massive amount of data that is called as a big data, where data is being produced from the sensor, actuator, communication data, computational data and storage. So this is the infrastructure at the backend side, which is going to the metaverse engine. So metaverse engine consists of the interactivity, where AR, VR, XR, MR or brain-computer interface also. Now think about, you are not able to speak. So brain-computer interface can convert your thought process into the speech. It can convert. So whatever I will use those sensors, whatever I am thinking, that will be converted into the speech, and then interaction can happen. So here brain-computer interface can also better help. Then scene creation, that is using the AI. Already we have seen the best suitable example is avatar. It is creating what? Your own same object. Scene rendering, translation, recommendation. Similarly, digital twin, which will perform the data fusion, 3D simulation, 3D modeling. Blockchain is here, it is helping for the NFT trading, NFT ownership, transactions, transaction performance. At same time, if data is being stored on the blockchain, we have seen the various applications of the blockchain. All these applications can be brought on metaverse, and that data will be being verified on the blockchain. Similarly, NFTs can also work on blockchain, and you can prove the ownership of the objects on NFT. And obviously, if you want to, if it is required to build some business logic or any rules, smart contracts are also required. So here blockchain can help. Using such metaverse engine, you can create the digital avatars. So this linking is showing what, with using this engine, you can create the digital avatars. You can create the virtual environment. That is depending on data. If I want to create the virtual world of the Goa, map of the Goa should be given first. Then different, what I can say, where this beach is located, what are its data, what are the information, all data are required. That is, then virtual goods and service. So as I gave the example of Goa region, whatever products are coming from the Goa, those product information and accordingly those objects should be created by using that information. And at front end side, it can have the like digital life. So you can have the multiple virtual world. It is not like it is creating one virtual world. I want to experience that moving from Goa to the Singapore. In virtual world, I can take the flight. I'll experience that how I can travel from in a flight from Goa to the Singapore. And there may be two virtual worlds. One is for Goa, one is for the Singapore. And I can travel also. I want to go to the moon. I can travel also. Thing is that it is like completely like imaging world with the virtual objects. So you can travel. And you will experience the time and everything. But everything is depending on the data feed. What data feed you are given. Fine. So blockchain in metaverse, how it is helping? It is allowing you to create your digital asset. That is like core functions provided by the blockchain. You can create your digital assets, not only the non-fungible tokens, you can perform the transactions in the form of cryptocurrency, like ERC20. So now people are very crazy. What they are doing? I want to purchase one digital object. How I can purchase? How person will sell it to me? I have to transfer some cryptocurrency instead of my cash. So if I am holding the, let's say, some cryptocurrency, based on the contract, I'll transfer cryptocurrency to that person in the virtual world, and I can purchase that digital object. Now monitoring, tracking is very difficult, and it can affect any country's ecosystem. Because where this money is going, it is in the virtual world, where cryptocurrency can also be being, cryptocurrency transactions can happen. In physical world also it is very difficult to track such transactions. In virtual world it will be far, I can say it will create more complexity. So Bitcoin and other cryptocurrencies are being used to purchase and sell the virtual assets in the metaverse. Using the blockchain, assets, or it can be money or anything else, can be transferred and used across all the virtual world. So blockchain here it is providing the decentralized open source ecosystem. Same like physical ecosystem, in virtual world you can have the same open source ecosystem that will allow user to design applications and conduct the digital commerce. At the same time, it is offering the data privacy and security, because if data is being recorded on the blockchain, there are different data being generated from different sources in the metaverse. It may be from wearable devices, it may be from IoTs, it may be from sensors, it may be from the real world data. So data and transaction data is also there when you are performing the transactions from one outside to the another. Communication data, everything, if it is being recorded on the blockchain, then it will offer the data privacy and security. Obviously, if data is immutable and data is available, so obviously it will improving the quality of data also, because the data is being loaded with the confirmation from the multiple nodes, as same like the blockchain. Seamless and secure data sharing. Now data sharing, here all the nodes are having the copy of same ledger. So sharing means everyone is having copy of same data. So sharing is very seamless and it is secure. Data interoperability. Blockchain interoperability is also one of the issue. Data interoperability is saying that if I am having NFT on one blockchain, I should be able to transfer that NFT to the another blockchain. But at some level of data interoperability it is provided. But still it is a challenge. Obviously, data integrity is maintained because data are immutable on blockchain. So this is the overall, I can say that, architecture of metaverse, that how blockchain can help in the metaverse. So if I will start with the data acquisition is the first and foremost model of the metaverse, where you can have the AR, VR devices, haptic gloves, AI boards, smart devices, smart glasses, all are interacting. And this data validation is required. And this data should be immutable. So blockchain is providing what? Data immutability feature. Similarly, we need to store that data. That data should be stored on the secure storage, where blockchain can apply. And that data should have labeling. So here NFT can also be stored on blockchain, and labeling means ownership of that data is there. Similarly, data sharing. So transparency among the data sharing should take place, flexibility and adaptability. So here blockchain is helping for the secure data sharing. And transparency will, obviously blockchain is providing the transparency. Data interoperability. Blockchain in the integrating blockchain in the metaverse, it is providing the complete decentralization, which was not there in the earlier metaverse of the centralized metaverse, but now metaverse is the decentralized. And it is having the wide variety of applications. So this is like linking at the user level in the metaverse, that how interaction is taking place, how data is being transferred, and between user and metaverse, you can keep the blockchain. I am just showing the small example. It is not like single blockchain network. It can have the multiple blockchain networks also, where real-time sensor devices will be there. So IoTs are fetching the real-time data, sensor data. It can lead to the different tasks, and that data can be on the blockchain. Similarly, historical data models are enabling the digital twins. If I want to enable the what I can say, virtual world of the Goa, if I want to enable, I need to set up the digital twin by fetching such data. Then AI is based on the user input, real-time historical data, so decision. So blockchain, as it is having the immutability and security feature, it is providing the data standardization also. And machine learning and AI are having the good accuracy if data are standardized. So here blockchain can help. Similarly, big data, categorized data, then XRF, so speech, eye tracking, gesture, VR, AR. So that is related to the immersive experience. And back-end side, you are having the integrated blockchain with the metaverse. So role of blockchain is, I can say, vital in case of metaverse. Thing is that many challenges are also there. So this was like a introduction of how blockchain NFT are enabling the metaverse. But there are many challenges, security related challenges, implementation related challenges, regulatory and compliance related challenges are there, which need to be addressed. Fine. So this is the reference for the blockchain for metaverse. Thank you. Thank you. If you have any question, you can ask. Hello. Hello. 1 second. Yeah. So welcome to the lecture number 29. It is on the central bank digital currency and blockchain. So this is also one of the current topic where blockchain is better helping. So first we will see that what is central bank digital currency. Every country is having their own, I can say, fiat currency. You are having the like physical currency notes, 1 rupee, 10 rupee, 20 rupee, 50 rupees. But that you need to carry. It is paper based. You need to carry. To perform the transaction also you have to give. But that is like physical currency. If same value is given to the digital object, that is your digital currency. So every country is having their own digital currency which can be stored into their digital wallet. So suppose if I am having the mobile app, which is my wallet, instead of carrying the physical wallet, I will carry the digital wallet in my mobile and I will store my digital currency which I can withdraw or I can get it from some authorized bank where my account is there. So this is what the I can say central bank digital currency. But as it is like digitalization based, so blockchain is required for the security, immutability. So blockchain features are required for the proper implementation of the central bank digital currency. So central bank digital currency, it is a digital currency issued by any country's central bank. So every country is having their own digital currency. Its value is same. So try to understand the difference between the digital currency and cryptocurrency. Here the value of the digital currency is same like the physical currency. But in cryptocurrency, value is being changed. Similarly, like cross-border, if I want to perform the cross-border transaction, I have to convert my whatever value for that particular digital currency that should be converted to the what? That from where I am purchasing the items, where I am performing the transaction, that currency conversion should take place. That can happen through the physical currency as well as the digital currency. So it is like similar to the cryptocurrency. It is in the digital form, but value is fixed by the central bank. And many countries are developing the CBDC, that is like transition to the digital currency. And with the advancements of the digitalization, this is gaining the more popularity. Means you need not to carry physical currency. Then you will ask, sir, we are using the UPIs. That is also one of the kind of digital. But in UPIs, what is happening when you are performing a transaction? What is happening? The transaction is being authorized and verified by the bank. And then the transaction means whatever amount you are transferring, that is done through the bank. And then that person is getting that amount in the bank account. But here you can perform transaction between wallets. This is the difference between UPIs and the central bank digital currency. If I am having wallet, I'll scan the QR code where I want to transfer the money. Transfer of the tokens will happen between person, and later that person can redeem those tokens from the central bank. So there are different models that we'll see later. So in India, digital rupee, e-rupee, the value of one rupee is the one, as same like the physical currency, which is issued by the Reserve Bank of India. in digital form, and it is offering the features same like the physical cash, like convenient to use, guarantee of the RBI. If I am holding the digital cash in my wallet, so RBI is giving guarantee that I can redeem those tokens and I can get the cash. So here all I can say ecosystem of the transaction can happen through the digital currency instead of physical one. So it is like paperless transaction through the digitalization, and currency is also paperless. And settlement is happening at the bank level, maybe central bank or the authorized banks by the central bank. So e-rupee is stored in the user's digital wallet. E-rupees will be stored in the user's digital wallet and can be used to receive, send the money, and or make the payment for the transaction just like the physical note. Only just giving value. Even paper is also having value as it is issued by the RBI or bank. That is why it is having value. Otherwise it is just a paper. So same thing like digital currency, the digital object is having the value which is authorized and verified by the RBI. That is why it is having the value. Otherwise I can create my own digital currency, but it should have some verification features. Fine. It should not be duplicated also. Otherwise I can create an amount of I can say digital coins. So it should not have replication or duplication also. But what advantage is it is giving? Lowering the cost, financial inclusion, because as it is removing the intermediaries, as it is giving the less cost involvement for the settlement of the transactions, like peer to the person transaction or person to the merchant transaction, and settlement is happening later. So it is having the less cost involved, and that is why it can involve everyone everyone can be involved in this financial inclusion, and tracking can also take place there where transactions are happening. So it is helping for what? Preventing the money laundering. Fine. So you can track the financial crimes also. So it is like cashless transaction. So this is the report. These are the pilot banks where different apps are proposed. So these are the banks authorized by the RBI for digital coins or digital cash. That is what central bank digital currency. So e-rupee app is by the RBI. So if you go to the portal of the Reserve Bank of India, where links of apps are given, Android app and Mac OS apps are given, you can download that wallet and you can purchase the digital coins by paying the cash. Once coins are purchased, that coins can be transferred, and if somebody is giving that, your wallet will be maintained. Fine. If you are only purchasing, your wallet will have the nil value. Your wallet will be null. So CBDC is a digital form of rupees in case of the India, where UPI is the means of payment. UPIs are used for the payment. It is unified payment interface. It is for payment. It is not showing the currency. So in addition to being used for the payment, digital cash is also serving a purpose like storing of the value in a digital wallet. It can be withdrawn from one's bank account, and it can be kept separately in the wallet. In case of person to person and person to merchant payments, which is made at the CBDC QR. So I can just, through that wallet, I will scan QR and I can pay, same like the UPI. But UPI is showing what? It is for the payment. And this is the digital cash. In case of UPI, when you are doing payment, it is being verified by your bank, where your account is there. And also it is being verified by the bank, where the person is having account to whom you are transferring the money. And then financial settlement is happening and that person is getting that money. Fine. Otherwise, if transaction is failed, it takes 2-3 working days to settle it back, where it is having the cost involved. This is like service cost. But if it is allowing person to person, like wallet to wallet transfer of the digital coins with proper security feature, then it will be widely adopted. So for person to person or person to merchant payments, the functionality of scanning a UPI QR from a e-rupee app can also be enabled. In such cases, settlement will be based on the UPI settlement timeline. So there will be fixed period. Within that period, the settlement will take place. Now, these are the different types of CBDC. There are mainly two types of CBDC. One is the wholesale and another is retail. Wholesale is leading to the I can say that large value transaction, which is always happening what? Between bank to the bank, not individual to the bank. So wholesale CBDC is used by the financial institution and intermediaries to streamline the interbank settlement. It is only for interbank settlement. It is operating within the restricted ecosystem. The ecosystem is what? Among the banks or financial institutions. It enhances the efficiency, speed and security of the wholesale payment system by using the functionalities of programming and smart contracts. But that is among the banks. For the, I can say that large value of the transaction, large value transactions. It is focusing on improving the financial systems infrastructure and reducing the settlement risk. So it is among the wallets. And if blockchain is involved, all the transactions are being recorded on blockchain. So trust will also be there. There will not be error. Coming to the retail CBDC, which is meant for the individuals, where you are doing the daily transactions. That can be done like wallet to the wallet or person to the person. Again, there are two types of, I can say, this is another category. You can categorize the CBDC transaction. One is the account based, another is the token based. In account based, you have to prove your identity. Where in token based, you are proving identity based on holding some certificates. That is your token. So in account based, ownership of CBDC is linked with the identity whereby transaction is an update of a payer and payee balance. So like wallet to the wallet transaction. But token based format where ownership of CBDC is linked to a proof. I am encrypting or I am digitally signing that token and I am sending that token to you. So it is like same like the NFT. Is it same like the NFT or not? Yes. It is having the fixed value. But here you are performing the transaction by encrypting the transaction and the verifier will verify whether it is really coming from you or not by using your public key. There are mainly three types of model, CBDC model. One is the direct model, another is the indirect and hybrid model. In direct model, you can perform payment person to the merchant or person to the person via the central bank, where there is no intermediary like commercial banks. So all parties should hold an account at the central bank. Payment will simply be transferred from one account to the another, and all claims will be backed by the central bank. The central bank issues the currency and manage the permission system to clear the transaction. In addition, the features like know your customer and anti-money laundering complex requirement all can be met by the central bank. But when commercial banks are involved, it is like indirect model. In this indirect model, central bank pass the digital currency tokens. Central bank will pass the digital currency tokens to the commercial bank same like the physical currency, where RBI is issuing the, I can say, physical currency to the banks, and you can perform settlement with the commercial bank, but there will be settlement between commercial bank to the RBI. So in this case, the tokens are given to the commercial bank or non-bank financial institute like fintech, which then distribute the currency and handle the KYC and AML requirements. The claim for currency is on the commercial bank, not at the central bank. This is what the hybrid, this is what the indirect model. But there is a hybrid model also, where it is a big proposal of the central banks are working on the hybrid model, whereby the central bank distributes CBDC to a regulatory intermediaries. Otherwise, it may reach to the water. Whole work is happening at the central bank. If it is like centralization, work should be distributed here in this case. That is why intermediaries are there, commercial banks are there, which are given the authority to further give the or distribute the tokens to the individuals, same like the physical note. But the claim will remain on the central bank in case of hybrid model. But the KYC and AML requirements should be fulfilled by the intermediaries. So in case of wholesale CBDC, it will obviously use the direct model, because there is a settlement among the water. Settlement is like bank to the central bank, not from the individual user to the central bank. In retail CBDC, you can have the direct, indirect, and the hybrid model. So indirect model can be called as a two-tier model. So if I'll talk about the retail CBDC, monetary system is like customer is there, he can have the cash, he can have the direct claim to the central bank. Another is retail CBDC, direct claim via the central bank through the wallet, not through the cash. Similarly, bank deposits or savings are there. You can have the direct claim to the commercial bank, and commercial banks are doing the settlement with the central bank. This is what the architecture or procedure between retail CBDC and monetary system. Now coming to the Bank of England. So this is the proposed two-tier CBDC model. Now before going through this two-tier CBDC model, what CBDC is offering? It is offering the what? Resilient payment system landscape, avoiding the risk of new form of private money creation. I'll tell you, physical notes can be duplicated or printed. Digital notes, if it is on blockchain, same like cryptocurrency, digital cash, or I can say digital currency on the blockchain, it is difficult to do this. So security feature is also there, supporting the competition, efficiency and innovation in the payment, meeting the future payment needs in a digital economy. So because it will be the fast settlement of the transaction. If I want to transfer money from India to the USA, I can use the cross-border CBDC. But if I am going to the one of the shop in my region and I am purchasing item, I can transfer the digital cash or digital coins or digital currency from wallet to the wallet. So it will be faster settlement. I need not to rely on my bank at that time. Otherwise, you might have seen many incidents. You are going there, you are scanning the QR code, then you have to wait for the approval. And if that server is down from bank side, then you have to wait, or you have to find the another option to perform the transaction. Improving the availability and usability of the CBDC, central bank money, addressing the consequences of decline in cash, because cash decline will be less compared to the other form. It is as a building block for the better cross-border payments. So this is two-tier architecture by the Bank of England, where users have to register with the payment interface provided to access the CBDC. Payment interface provides the authorized and regulated firms, providing the user-friendly interface. So the banks and others are kind of like intermediaries. And there is a central bank core ledger, which is issuing the tokens for the intermediaries, and intermediaries are distributing the individuals. This is what the two-tier architecture. This is the overall current status. So you can track this status of the CBDC in this world using this link cbdctracker.org, and you can see that some of the CBDC projects are cancelled. So, but most of the countries are now going to adopt this. So most of the projects are the like proof of concept level at pilot level or launch level. In some of the countries still such projects are at the research level. So if you see in India, by February 2025, the CBDC project is at the pilot level, and already e-rupee digital coin is already introduced in India. Now this is two-tier, I can say CBDC model for the cross-border CBDC. Now I am talking about the involvement of two CBDC. Within the country, you can have the one CBDC, means one central bank digital currency, and you can perform the transaction like person. But when multiple CBDCs involved, you can perform the what? Cross-border transactions. So consider the infrastructure tier of the CBDC1, which is in India. Infrastructure tier 2, that is CBDC2 in, let's say, in USA. So central bank, there will be central bank which is issuing the CBDC, which is issued to the intermediate authorities, who will distribute those CBDC tokens to the users. And these transactions can be monitored on the blockchain at the India level. Because the transaction can happen what? Among user to the user, user to the bank, or user to the merchant. All transactions can be monitored within at this CBDC infrastructure. Now I am talking about this user would like to perform transaction to a user or merchant in another country, that is CBDC2. There should be some interface. There will be interface. So in this paper, they have mentioned the universal payment channel. So these are at the research stage, different solutions are there. I am just showing you one example where user with wallet provider can perform transaction to the user in USA who is also having the wallet, and you can perform the transaction. And this currency conversion will take place by the taken care by the UPC hub, Universal Payment Channel. This is what we are doing with the international credit card also. Fine. But here all this will provide the faster and efficient way to perform the transaction. Now what is the role of blockchain in CBDC? So in this diagram already it is mentioned, the transactions should be recorded on the blockchain. So, and it will build the trust on the CBDC. Otherwise, if transactions and what your CBDC is given to the users, if there is no monitoring and tracking, it is difficult to build a trust. If I am performing transaction to you, and if I am not able to see that whether the transaction is done or not, in your mobile wallet it will be reflecting. Tomorrow it can be deleted, but it should be recorded on blockchain. So it will provide the what? Tamper-proof evidence that I have transferred coins to you. I have transferred digital currency to you. Smart contracts, so you can provide the also within smart contracts while performing the transactions. Security, data will always available through the blockchain. So blockchain is offering such features to enable the wider adoption of the CBDC. Data availability will always be there. Data integrity. Then efficiency, because it will be the faster settlement compared to the other form of performing the transactions. So this diagram, this table I have taken from this one of the paper where comparative analysis done between traditional banking, digital banking. This is what currently we are using with net banking. That is what digital banking, or with mobile, whatever we are doing with bank, that is what digital banking. Then CBDC, blockchain based CBDC. So control structure, if you see, traditional banking is centralized. Digital banking centralized. CBDC centrally managed by the central bank. But blockchain is the decentralized. So CBDC with the blockchain can give the two things. Control is with the central bank, but structure is the decentralized. So it is providing centralized as well as the decentralized approach. Security level, where blockchain is there, it is high with the central bank security and cryptographic technique. Transaction speed, this is providing the fast using the centralized control, because control is given to the central bank, where transactions, recording and other things are happening on the blockchain. Cost, it is very low to the moderate level of cost in case of the CBDC with the blockchain. Accessibility, high dependent on the national infrastructure. So accessibility we cannot evaluate now. How infrastructure each country is, how each country is investing on infrastructure and building the infrastructure of the blockchain and CBDC. Then we can give the comment on the accessibility, that how much it is user friendliness. Currently apps are developed, wallets are there, but infrastructure like blockchain nodes, trust mechanism. So you can apply the proof of authority. Obviously, authority is required to confirm those transactions. You cannot go with the proof of work. Or if you are going with the proof of work, again, only authorized users should be able to perform that block mining. So it is better to go with the proof of authority. It is providing the immutable records due to the involvement of the blockchain. Smart contract, which depends on the policy. Which policy or what kind of policy that central bank would like to enforce for performing the transaction through the central bank digital currency. Based on that, policy can be enforced in the form of the smart contract. Regulations. So strictly regulations by the central bank. Infrastructure, it is centralized and decentralized network nodes, and service is 24/7 hours. But in case of traditional banking, it was limited hours, working hours are limited, and that is why it has given a birth of the digital banking, and after digital banking, CBDC, now blockchain based CBDC. So high availability is there. Identity verification, so it will perform the strict KYC. Now recall the eKYC application I have covered on blockchain. If that blockchain is integrated with the CBDC blockchain, it will be very easy to perform the eKYC. Now you can think that this is like financial application of the blockchain, but there were other application of the blockchain can be integrated with this to streamline the work, and that is why national blockchain framework is exist. Because different blockchain, and it should create it like consortium of the different applications. Throughput, high, designed for the large scale transactions. Scalability, which is also high nationally and scalable also to the cross border also. So I can say that blockchain is, CBDC is having its own advantages, and blockchain is helping for the wider adoption of the CBDC. So this is one of the application of blockchain in the financial domain. So in this course we have already seen that blockchain is helping in the various e-governance with various domains. This is also one of the domains where blockchain can give the promising results. Thank you. If you have any question.
Hello, hello, 1, 2, 3, 4, 5. Good morning and welcome to the last lecture in this course. So in this lecture we are going to consider yet another blockchain related topic. So we have finished with the sequence of use cases, and the last lecture is dedicated to yet another technological topic of blockchain-based storage. And we also will take a quick look at the future perspectives when it comes to research in blockchain. So blockchain-based storage, it's diverse, it's and numerous. So what you can see here, IPFS, Storage, Swarm, SIA, Filecoin, Safe, and Arweave are probably the main ones, but there are also quite a few additional systems. So they're diverse in the sense that they provide different functionality. So each one, they are not mutually interchangeable, and each one pursues a slightly different purpose. Some additional systems which I am not mentioning are integration of a database with blockchain. So there are systems that orient themselves in that direction. So the very first attempt, or successful attempt, the very first system of storage based on blockchain is called the Interplanetary File System, or IPFS. So the name is a bit presumptuous, as you can see. So the idea of IPFS is to link decentralized data together. So the assumption is that pieces of data, chunks of data if you want, are stored inherently in different locations, and we need to find them and link them together, and this is what the system is doing. It's maintaining the linkage between different pieces of information. So the data is assumed to be immutable. If you want to update the data, you can do it, but you do not replace the old data. You just create a new piece of data and you put it elsewhere. And you can just rearrange the links. But the old piece of data is not being modified. The addressing is content-based. What does it mean? It means that the addressing never goes by locations or endpoints. The location always goes by names and hashes of the data. So we are going to see how IPFS implements this functionality. IPFS uses blockchain for two different purposes. First, it uses blockchain internally. So individual nodes may be incentivized to store pieces of data. So there are monetary incentives. So if you want someone to store a piece of your data, you may want to pay that someone. And in fact, they came up with their own cryptocurrency named Filecoin. And IPFS may be supported by Filecoin. However, the connection is modular, so you can use IPFS without Filecoin if you want, or you can integrate it with Filecoin. Now, the second way in which blockchain is used in IPFS is to secure the hashes. So the whole structure, after created, can be secured by hashes of all the links, and those hashes can be stored on the chain. This is usually what the application built on top of IPFS is doing. So it's not the functionality of IPFS itself. IPFS only provides those hashes, but the application built at top could store those hashes on the chain. This is not mandatory. I mean, it's up to the application. And the design, which we are going to discuss soon, borrows ideas from all technologies of BitTorrent, Git, and Kademlia. So Git is a file versioning tool, and while BitTorrent and Kademlia are systems for, well, that like Kademlia is a DHT, so distributed hash table, well used in the context of peer-to-peer file sharing, but in general the DHT is used for finding locations of individual pieces by names or caches. And BitTorrent is a system for file sharing, which uses some sophisticated ideas about how the different files can be exchanged in the most efficient way. And those ideas are used in IPFS. So IPFS elements are the following. It has the concept of IPFS identities. So we need to manage node identity generation and verification that is the correct identity, that the node is not trying to falsify someone else's identity. Network manages connection between the peers using various underlying network protocols. So it's the same as in peer-to-peer networks. Routing maintains information to locate specific peers and objects. So it defaults to an DHT based on Kademlia, but it's possible to use something else. The exchange protocol is how those pieces of information being transferred over the network. So they develop their own block exchange protocol or chunk exchange protocol. It's not exactly maybe right to call it blocks because it's not blocks in the same way you would call blocks on chain. So chunk exchange protocol called BitSwap that governs efficient chunk distributions. In fact, it's modeled as a market where you can sell your space, storage space, and where you could pay for someone storing your data. Objects, I'm going to discuss it soon. So an object in IPFS is modeled by a Merkle DAG of content addressed immutable objects with links. And it's used to represent file hierarchies and in general arbitrary data structures. So files are versioned using file system hierarchy similar to Git. And finally, there is the naming component which provides self-certifying mutable name system. So let's delve deeper into Merkle DAGs in IPFS. A Merkle DAG in IPFS basically consists of different chunks of information. So each node is a chunk of information. And then there is a link. So there is a top of the hierarchy of the file system. And from there, you can have folders, but folders not in the direct sense of the file system. It could be rather collections of information. So the links are not like not links of the operating system. It's more like high-level URLs with some additional security guarantees. And it's a DAG, it's not a tree, right? Because the same chunk can be referenced from multiple chunks at the upper level, from the multiple vertices at the upper levels. So each link contains 3 pieces of information: name, hash, and size. All are used for the purpose of verification, but the name and hash are also used to physically locate the chunk from which data can be downloaded. So let's take a look at an illustration of what happens with the Merkle DAG when the file is being modified. So as mentioned, the old version doesn't disappear, a new version is created, but how to do it in the most efficient way. Okay, so suppose that we have some file f, which is broken into two chunks, A, B, C, D, and set within each chunk there is a further division into A, B, and C and D. So A, B, C, and D, A, B, C, D, and then A consists of A0, A2, A2, B0, B1, B2, C0, C1, C2, D0, D1. Okay, so that's the initial situation. Now, let's assume that we want to modify the file by changing D, so now D becomes D prime, and also appending EF at the end. How would it affect the Merkle diagram? So as you can see, this part is not affected at all. This part is not affected at all. Now here, what do we change under D? We add another chunk, D2, to the previous chunks, D0, D1. So we simply add it here as another leaf and recalculate the leaf. And here we also have to create a new vertex because the old one cannot be used any longer. Now here we simply add the entire subtree and we link it here to the upper level. And of course the upper level also has to change because of that. So as you can see, this part would be changed. This part would be changed, this part, this vertex, and here the entire subtree would be added. So what's the main point? The main point is that those can still be reused and linked from both the old version and the new version. Okay, so that's about IPFS. The next system I would like to talk about is Swarm. Swarm is built by Ethereum, and it uses Ethereum-specific elements. It also uses content-based addressing. However, its philosophy is different. In IPFS, we are trying to link pieces of information which is already stored and which already mostly exists in the system. Well, we can increase the amount of replication, but in principle, IPFS doesn't try to rearrange the storage. It only aims to link existing storage pieces. In Swarm, it's the opposite. In Swarm, we want to place files, and we decide on the location of placement based on the files. So the assumption in Swarm is that the storage doesn't exist in the initially. We need to take care of it. Okay, how does Swarm do that? It also uses content-based addressing, but differently from IPFS, the hash determines the location. So in Swarm, you calculate the hash of the data, and based on the hash of the data, you determine, like using DHTs, you determine on which of the many nodes in the network the data will be stored. Mutability is supported by version in the same way as IPFS, and Ethereum name service is used for finding the mutated files. The system is implemented, the whole system, or at least most of the system, the name service and some other functionalities are implemented as a contract at top of Ethereum. And like IPFS, it also uses a DHT Academia for the communication. Swarm additionally provides an incentive layer where nodes can buy chunks of data, of stored data, but also where nodes can be paid or incentivized by storing additional replicas by paying. So, for example, you calculate the hash. You decide that based on the hash the data needs to be stored on that particular node. The node needs to be incentivized, and the nodes are incentivized by earning Ether. So it's highly integrated with Ethereum. This is conceptual overview of Swarm. So first, okay, so suppose the user wants to add some data to the network. So this is the network. Okay, what does the user do? First, it creates a tree it breaks the file into chunks and creates a trio, cryptographic tree of those chunks. And then, based on the hashes, each chunk would be placed on a different vertex in the network. And of course, those vertices need to be incentivized. So obviously there are a lot of hashes, like to verify the consistency. And later, when someone needs to find the data, it will send the request, and then it would need to collect the chunks, individual chunks from individual nodes in the network, and then put them together and restore the original file. The next system we are going to consider is called StoreJ. StoreJ is again a bit different. In StoreJ there are three types of nodes: satellite storage and uplink nodes. Uplink are just the users who want data stored or who want to retrieve the data. So they just called uplink in StoreJ. But the satellite and storage nodes. So storage nodes are storing the data, while satellite nodes are responsible for the organization of the overlay of the network of storage nodes. So they're configuring the storage nodes. Now, StoreJ assumes that most nodes are rational. Rational meaning not Byzantine. They are not trying to bring the system down. So they are not aiming to tolerate one third of Byzantine nodes. That's not their goal. But they are also not assuming that nodes are just altruistic and following the protocol no matter what. They assume that nodes would be doing what they are doing for the personal gain. Now, in StoreJ, StoreJ puts emphasis on privacy, so all the data is encrypted. Another interesting distinguishing feature of StoreJ is high degree of redundancy and resilience to tampering. How do they do it? They use KN Reed-Solomon erasure codes. So what is a KN erasure code? We break, it's not even correct to say that we break a file into chunks. We take the entire file and we build pieces of information out of the file. But pieces of information are not just chunks. They are overlapping with each other. So we build, given a file, we build n pieces of information. But of those n, we need only k, and k is smaller than n, in order to restore the original file. So there is some degree of redundancy involved. So why do we do that? Because we assume that not all n pieces will be available. Maybe some of the nodes will be down, and we won't be able to retrieve the pieces. This is why we want some degree of redundancy. We assume that not all n pieces would be available, but we don't need all n, we need only k, which is a smaller number. And then all n pieces would be stored on different nodes in the network. Additionally, StoreJ uses an incentive system with node audits, and StoreJ also maintains reputation of individual nodes, which is collected. So for example, it's not enough that someone says, oh, like I didn't get a chunk from that node. So a reputation system would be collecting votes and ranks from different participants, and if many participants rank the same node as misbehaving, then this is what would be reflected in the reputation system. So here's a conceptual overview of store J. So given a file with or piece of information, we build what's called stripes, and from that we build erasure codes, right? And then we distribute the erasure codes in a different way over the network. So after we have the codes, we need to decide about the right place for each code. And here you see the network. So there is one satellite node. Those nodes are simply representing the user, right? So they are user nodes, or uplink nodes in their terminology. And those are the storage nodes, which constitute the majority of the network. So we can also build different taxonomies of blockchain-based storage systems. So here in this slide, we see the taxonomy based on the underlying network. Some of the systems are using structured network based on DLTs, while some other systems are using unstructured network. And in unstructured network, we typically just there is no, like the topology of the network is self-organizing and maybe like chaotic, not following particular structure. That's why it's called unstructured. And usually, in order to find something in an unstructured network, you need some discovery mechanism, usually done by partial flooding, but also could use DOTs for more specific purposes. A different topology is that of incentive mechanisms in storage-based systems. So which incentive mechanisms do we have? We can reward the node for storing information. We can punish the node for not behaving properly. We can charge the node for uploading and propagating pieces of data. Sorry, the other way around. The node can charge, if the node participates in the propagation of data, not just storage, but also propagation, it may expect a reward and charge certain fee for doing that. There could be some trade of data, like I'm selling you this piece of data for that much, so it's like a marketplace. And of course, sometimes like retrieval, if I want to retrieve some piece of data, I need to pay for that as well. Not all mechanisms exist in all systems. You can see that some of the systems would appear in multiple places here because they implement different mechanisms, but there is not one system which implements all of the mechanisms. Again, there is diversity between the systems. Okay, so this concludes the brief overview of blockchain-based storage today. And the second part is the outlook towards the future directions. So generally speaking, people believe that blockchain will be used, like it will not conquer the world, but it will be used as a dedicated technology and part of the bigger infrastructures, but especially in application domains related to energy markets and trading, digital currency and finance, agreement-driven healthcare provision, and record keeping. And of course, record keeping is also a very big domain, right? So you have identity, IP rights, digital rights, land registry, supply chain. We've seen a lot of use cases related to that. So one of the directions of future research, of course, is to continue developing this ecosystem and also understanding what blockchain is good for and what blockchain is not good for and how to use it in the most optimal way. So far, there is like by the count, we are now in blockchain 4.0, but of course it's like the division is arbitrary. So what can we expect in blockchain 4.0 or any future type of blockchain? What challenges remain and what challenges will arise in the future? We already talked about many of those challenges, so scalability in terms of the storage, number of participants and throughput rate, interoperability, which consists of bridges between competing blockchain systems, and variety of atomic swap procedures with different trade-offs, privacy in blockchain applications, including zero knowledge and other techniques, new proof of something schemes, and better protection against attacks, especially these days. Perhaps the MEV attacks are the most intensively explored topic in security of blockchain. Additionally, in some companies offer blockchain as a service in the cloud. So we have infrastructure as a service, we have platform as a service, we have application as a service, but they are also offering to make blockchain as a service. So Microsoft, for example, is offering this. However, it's interesting how you meter the use of blockchain, right? Because significant part of offering something as a service is metering. So in infrastructure, we measure the consumption of storage, the consumption of computation, the consumption of bandwidth, and then we charge for those, for exactly the amount of resources consumed. So how do we do it with blockchain? So already there are some suggestions, but this is still developing. Smart contract enhancements are again like multifold. So the languages are still developing. The idea of how to execute contracts is still developing. How can we make the contract execution obviously more efficient and cheaper? How to integrate contract execution with trusted execution environments, that's another area. And how to build tools for debugging and testing smart contracts. So all those areas are being explored. Speaking about tools, so tools of course exist in the context of smart contracts, but they also exist, or they are also important in other contexts. So for example, I already talked about blockchain simulators and generator of synthetic workloads, and there are also emulators which are different from simulators, right? Integrators and composers. So under Hyperledger, some of the projects are about how we build applications with focus on integrating blockchain as individual components. So this kind of compositional tools also being developed. Recipes and design patterns. So as different pilots and use cases continue to emerge, we gather better understanding about how to integrate blockchain within infrastructures of real life scale and complexity, what to store on chain, what to store off chain, and how to provide the end-to-end verifiability. And in the context of POW especially, but in general, there is a question of sustainability of blockchain, green blockchain if you want, which was originally inspired by the fact that Bitcoin is consuming so much energy. So I'm going to expand a bit about the last part. Sustainability of blockchain. So one direction on the sustainability of blockchain is to replace crypto puzzles in the context of POW with useful computation. But the problem of crypto puzzles is not only do they burn such amounts of energy, but also finding a solution to the crypto puzzle doesn't benefit humanity as a whole whatsoever. It only benefits the miner who got the reward, and maybe benefits the blockchain ecosystem in the sense that we make progress and the chain becomes longer. But the solution to the crypto puzzle itself is not like a solution to any important problem for humanity. Okay, so the idea here is to replace crypto puzzle with some useful computation, and people have been exploring this idea from 2013, where the first idea of Prime coin came out, Prime coin, then Gap coin, and then a lot of different attempts from 2017 until 2023. So what are they trying to do? What are the type of tasks they consider as candidates for replacement of crypto puzzles? Well, mostly they consider machine learning, optimization problem, linear algebra problems, and also and also prime number decomposition or factoring of prime numbers, like in cryptography. Those are the 4 most popular classes of tasks explored as in the context of replacing crypto puzzles. So for machine learning, there are works that focused on deep learning, neural networks, and others. For linear algebra is it's interesting because linear algebra is easier, not as hard as other classes on this list. So how can we use it? Well, we can use it if we make the matrices on which we perform the computation big enough. The problem with this approach is that in order to build a hard instance, we need significant amount of storage for storing the matrices. A similar problem arises in the context of machine learning, where we need large data sets. So which usually it means that data sets themselves cannot be stored on chain. So we have to store it off chain and just integrate the off chain storage with the on chain storage by securing the hashes. So optimization problems again multifaceted. So there is the traveling salesman problem, but there are local search problems. Some of them we're exploring the SAT problem. Yeah, quite a variety under optimization problems. So how do we extend support to, how do we extend the architecture of Bitcoin to support useful tasks? So here again you see the standard layers, and in the standard layers, like this is consensus layer or data manipulation, this is storage layer. Those two layers are affected by the replacement. Now the main changes here, what you can see is like those colored boxes are the changed information. So the POW mechanism is changed, block validation is changed, block storage is changed, transaction pool needs to be updated with respect to the class of task being used. But there is also a new box here. There is a need to maintain a supply of tasks. So crypto puzzles can be generated on the fly by the miner, while useful tasks need to come from somewhere. So who is going to supply them? Then one model is to introduce dedicated suppliers in the system. The other model is to say that any instance of a particular class of task is considered to be interesting. But in this case, the utility would be more limited compared to the case when a supplier provides the useful instance. How do we define the utility, right? So what's the status of this direction of research, of replacing crypto puzzles by useful classes of tasks? So it turns out that despite the numerous attempts, no one has been able to achieve all the guarantees of crypto puzzles, though the research is still ongoing. And the reason for that is the multiplicity of requirements. So crypto puzzles appear very simple. So when we looked into this, we were amazed to discover how many different properties crypto puzzles satisfy that are essential in the context of POW. So what are the properties? Well, we need to be able to solve crypto puzzles fast. Crypto puzzles need to be hard enough. If they are not hard enough, that the blocks will be produced too fast. But on the other hand, not too low, because otherwise the blocks, if they are produced too slowly, the chain would not grow fast enough, right? So, and we need to moderate that. So we need to be able to adjust the time to spend on the solution, both from below and from above, right? And we need to be able to do it dynamically. Context sensitivity means that the useful tasks needs to be connected, tied to the particular context or particular block. Because the idea is to prevent reuse, so we cannot take some past solution of the useful task and say, okay, we reuse the solution again. And we prevent it not by maintaining some database of everything that has been solved, but rather making sure that the instance of the useful task is derived from the context of the useful task. And the context would include the already existing chain of blocks and the list of transactions we want to include. So that's called context sensitivity, very essential. Similarly, non-amortizability. Non-amortizability means that if someone has been solving useful task for a long period of time, that someone would not gain any advantage compared to the newcomer. So it means that the cost of solving useful task would not be amortized over time. It's yet another property satisfied by crypto puzzles. Okay, if I spent all my year solving crypto puzzle and I don't gain any advantage compared to someone who starts today. Non-zero variability in the solution time. That's also very important because we don't want everyone to propose blocks at about the same time. That would create a congestion and branching. So we want significant variability in so if you look at the distribution of time, like how fast blocks are proposed, so we know the average. But it's not only about the average. There is significant variability in the time to propose a block. And crypto puzzles satisfy that. But many useful tasks do not. Okay, some of the properties are quite obvious, so we need to generate tasks efficiently. Well, if we need to train a model, it won't be an inefficient task generation. We need to verify the correctness of the block and of the task solution efficiently. So task needs to be hard to solve, but needs to be efficient to verify. We already talked about the property of fairness. Fairness means that if I have twice as much resources as the other node, my chance to propose a solution needs to be not higher than twice the chance of that someone to propose a solution. So what we want is to prevent superlinearity in the dependency. So there's dependence of the probability to find a solution on the amount of resources possessed by a single node. In this case, we need this dependency not to be superlinear. That's important for fairness. It's another challenge. Another interesting one is blocks. We call it block switchability. What is block switchability? Suppose I'm mining the current block, and then someone managed to beat me to it and sends a proposal. So how much do I lose from switching from mining my current state of mining on top of the previous block to the new state of mining on top of the recently proposed block? So a very important property of crypto puzzles is that I don't lose. Well, of course, if I beat the other block, maybe it would be good, but I don't lose anything. I don't lose due to the if I have been mining on top of a certain block for a period of time, I have not gained any advantage. So if I switch to mining on top of another block, my probability to find the solution would not be reduced. That's a very important and nice property of crypto puzzles. It does not exist for many other classes of tasks, because mining can be a stateful process. If finding a solution for a class of tasks is a stateful process, then I've already been accumulating some state. Now, if I switch to mining on top of a different block, I would be losing that state. So that's a problem. So when I switch, there should be no reduction in the probability to find a solution and no reduction in the expected time to find a solution. So you can see it's quite surprising how many different properties crypto puzzles satisfy, and that's essentially the reason why none of the many, there are quite a few proposals that explored that came up with sophisticated technique to provide a certain property, but no proposal covers the entire spectrum of properties. So this is why the mainstream cryptocurrency system based on POW are still using crypto puzzles and not any alternative, not any useful task. So this is the end of the lecture. And I would like to thank you. It's actually interesting. Thanks for your attention.